Let's get into the big topic of open source, something that we actually say at Red Hat.
This is so
We
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say,
As the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. Man, you'd think 97 episodes in I could get the name right on the first try without having to engage my brain.
never.
Yeah, hello everyone, welcome. My name is Andrew Sullivan. I am co-host along with and joined by my very good friend, Johnny Rickard. How are you, sir?
I'm good, buddy. How are you?
It's another beautiful Wednesday. So, second best day of the week right after Friday.
That's
so
right.
getting better by the minute. We're here. We're ready to do this thing, ready to explore some really cool stuff. I'm excited.
It's happening.
Yeah. This one, it seems to happen more often than not these days because we're both super busy. I won't say we came up with this one last minute, but it was pretty close to last minute.
Mm-hmm.
But it was born from a new feature in 4.12, which is control plane machine sets. It's something that we've been talking about, at least inside of Red Hat, for, like 2 years, at least 4 or 5 releases, as being a way that we can manage control plane nodes the same way that we manage any other node type, right, through a machine set. There's some really cool stuff that we can do with that we want to look at today and see a demo of. And then the other one is infra nodes. Infra nodes are something that seem to come up pretty often. A lot of different questions. For me, like when I see questions about infra nodes, it's about 50-50 between how do I configure, how do I use infra nodes, and what am I allowed to run on infra nodes? So Johnny and I, we talked about this a little bit yesterday of like, maybe we should start doing some, for lack of a better term, back to basic stuff. It occurred to me that we haven't done like an install. I mean, we've done some install things, right? We talked about like an agent-based installer. We've talked about assisted installer. We've shown IPI and a couple of different things, but we haven't done like a back to basics vSphere UPI or bare metal type of install. It might have been one of the first 10 episodes of the stream, and that was 3 years ago, coming up on 3 years ago. So it feels like it's time to go back and start looking at some of that stuff. So for anybody who's out there who's watching the stream, either live or recorded, if you have any suggestions, thoughts, anything that you'd like to talk about or see that's for lack of a better term, back to basics, because we all got to start somewhere, and sometimes we forget about those basics things. I know I sure do.
Oh yeah.
Let's start investigating that. Let's see what we can come up with.
Yeah, and as my good friend Lester likes to say, it's good to have like a solid base of foundations, right, or solid foundation of fundamentals. So you okay, here's how I create a basic application to make sure that my cluster is doing what it's supposed to be doing. Here's how I know that my cluster is up. Just have that nice fundamental baseline and then move on from there.
Yeah, that's another interesting one. Of how do I should write this down. Hey, like how do you test? How do you validate? That a cluster is ready for production. And of course, that's going to be different for everybody. Everybody out there. What your requirements are, what all that type of stuff is. For example, some folks, I'm going to pick on the logging. Some folks, logging is absolutely critical. Must be there. Cannot have a gap. Has to be bulletproof type of thing because regulatory compliance. For other folks, it's logging would be great, but it's a lesson. It's not a tier A cluster, right? The stuff that's happening here, it can go away. Or the applications have their own log mechanisms. We don't need to do it at the cluster level. So, but anyways, it's an interesting concept, right? Login failed will kill you. That doesn't sound good. Anyways. So this is one of the Office Hours series of live streams here on Red Hat Live Streaming, which means that Johnny and I are here for you all. So anything that's on your mind, anything you want to ask about, anything you want to talk about, feel free to bring it up in chat. Whatever platform you're on, whatever YouTube channel, Twitch, etc. It'll get rebroadcast across all of them, so feel free to ask, and we'll do our best to answer those questions. That being said, we of course always have a topic that we talk about and fill in, if you will, with. But we're happy to talk about those questions as well, and that's really why we're here. If you're not watching us live, please still reach out to us. We love to hear from you all. We love to get those questions. A lot of times we'll bring them up here on the stream to chat about that and kind of make sure that it gets out there. You can always reach out to me via email at andrew.sullivan@redhat.com. Or you can reach out to me on the various social media platforms at Practical Andrew. So Twitter and Reddit and all of the others. I should really join Mastodon. I feel like that a lot of the technical folks.
Yeah.
There's a good chunk of them that moved over to Mastodon, but
we're behind the power curve now, right? Still using Twitter, looking at other people's feeds.
Yeah.
So
I still have this sticky note on the monitor of all the different places, Kubernetes, Slack, and like all of these other things of like where we are present at. There's one here that I can't actually read because LinkedIn, because my handwriting is terrible. I don't ever write things. I type things. So yeah, please don't hesitate to reach out. Love to get your emails. Love to hear from you. You can also reach out to Johnny. Johnny is at jonny@redhat.com or jrocktx1. Everywhere except for the Kubernetes Slack, where you're jrock. Consistency is hard. We've had this conversation.
Names are hard.
All right. So as always, we of course have a few top of mind things that we like to talk about here before we get to the main content or the main topic of today. Let's see. Our Hope 9. Time to dust off Christian's contribution to Kubernetes again. Make MachineSet. I haven't actually looked at that in ages. I should go back and look at it.
And I think that there's something in. I feel like there's something in the works within GitOps itself where they're going to make machine set management a lot easier. They're just going to simplify the whole process. So, this is a good stopgap, I think, for now. And I mean, up until now or until they've released that feature. But I know I remember hearing something about machine set management being simpler with GitOps.
That'll be interesting to see.
Yeah.
Should is it Harriet? Yeah, Harriet was the GitOps PM that we had on.
Yep, I'll reach out to her and ask her.
Caldelis, apologies for butchering names. Is Dex supported by Red Hat yet? I don't know the answer to that.
It is in GitOps. So in OpenShift GitOps operator, it's using it's using Dex to authenticate, and then in 1.8, it's I think SSO and Dex together. So, but as far as across Red Hat, I'm not sure.
Yeah. I do know who we can ask about that though, so we'll take that and see if we can find out the answer. Let's see, top of mind. Let me find my document here. Let's see. So the first thing I wanted to bring up here is actually one I didn't put in the list, Johnny, but I'm going to quickly bring it up, which is upgrades in the stable channel from 4.11 to 4.12. So you will notice that they are not there yet. Let me turn this guy on and go to upgrade. No, you're not going to fill in for me. Fine. Path tool. Oh, and I'm not logged in over here. Fine. Jeez. I've been working from multiple computers the last week or so because I'm almost to the point of being able to move back into my other office. So
nice.
All right. So we've got the handy upgrade graph tool here, and if I go to the path, I'm going to select that I am currently on stable 4.11. We'll go with OpenShift version. I think 4.11.30 is the current stable. You'll see that none of these have an upgrade path available. So upgrade paths have not been promoted to stable yet. So there's a number of different reasons for this. We can actually go in and look if we go to github.com/OpenShift. And if I go into the Cincinnati graph data repository and looked at blocked edges, I can come down here and see, come on, lots of scrolling, so much scrolling. So I want 4.12.7. So we see that there's 2 blocked edge identifiers in here for 4.12.7. So I'm going to pick one of these, and it's saying from everything 4.11 to 4.12.7, it's blocking that edge, and it's blocking it for this reason. And then, I don't know, we've talked about this before, Johnny, of in modern OpenShift, it uses PromQL inside of the cluster to identify whether or not your cluster is affected by these things. So I always thought that was really interesting, because even even if you have a connected cluster, we don't get the information that we need to be able to say yes or no, your cluster is affected by this. It has to be done inside the cluster.
Yeah.
So what's interesting about this one, and you can kind of read through the notes here, if your cluster was deployed as an OpenShift 4.1 cluster, so way back when, do you remember OpenShift 4.1, Johnny? It was, I know AWS was supported. I think vSphere was supported. I don't know what other, there wasn't a lot of platforms supported way back when. We can look at this. Let's see. Let's go to docs.
I'm pretty sure I didn't even touch OpenShift 4 until 4.2, and then, I was primarily GovCloud user, and so then it really didn't do anything for me until like 4.3, 4.4.
4.1 installing. So you got AWS, Bare Metal, or vSphere. So yeah, it was way back when. So if your cluster was deployed 4.1 and has been upgraded over the years and now reaches 4.11, 4.12 status, there's a chance that it doesn't have this particular flag on Podman, I think. Podman. So this is one of those times where the conditional updates, that's the word I was looking for, comes into play. As the administrator, we can go in and we can look and say, oh, my cluster was deployed 4.11 or 4.10 or whatever. This clearly doesn't affect me, so yes, please go ahead and damn the torpedoes.
Mm-hmm.
Admiral Farragut, by the way. So anyways, if we come back here, and now I lost my tab, or I think I just closed my tab. This is one way that we can see all the different stuff that happens inside of here and get an idea of things that might be blocking. I do know that the team, normally we say 45 to 60 days after GA is when stable upgrades between minor versions are unlocked. I think we're a little bit past that 60-day mark at this point, but I know they're working diligently to get past that. The 45 to 60 is not a guarantee. It's just a window that they aim for. I haven't been paying attention to chat as anybody.
So RHOP9 asks why is 4.11.31, which is in both fast and stable, blocked from .30?
I don't know. That's a good point. 4.11.31, we can see kind of the same things here. But yeah, here you can see, here's the issue, leaked machine config. I don't know. That's an interesting one. It could be that, no, if it's blocked from earlier versions of 4.11, sometimes what will happen is we'll end up in a scenario where 4.10. I'm going to use a random number, 46 is blocked from upgrading to 4.11 something, even though 4.10.45 isn't. And that happens because the latest ZStream for, in this instance, 4.10, the CoreOS version is actually ahead of the latest ZStream version for 4.11. So you have to wait for them to catch up because they don't always release on exactly the same day at exactly the same time. Yeah, I'd have to dig around and figure out what's going on with 4.11.30 and 31. Waited for 4.2 before moving from 3.11. The Forge, I will admit that I joined Red Hat 4.5 years ago, and it was right before the 4.1 release. I spent the first 6 months that I was at Red Hat just trying to wrap my head around OpenShift 4. And so, upgrading even at 4.2 is pretty impressive there. I will kick you, because it was such a paradigm shift with operators and the way the deployment is done, just the install and the way cluster management is done with, like all of these other things was such a dramatic shift. What do you mean I shouldn't SSH into the node? Or what do you mean I shouldn't use Ansible to, control these things? It was hard for me to wrap my head around.
Me too. Especially like Ansible, I have an inventory. I've got it perfected. It works 100% of the time. It works 99.99% of the time. That part to me was like, it made sense. It took me a while to once I figured out like, okay, here's the step, here's my block diagram of how this actually works. And it helped me debug it, to be honest. And once I figured that stuff out, I was like, oh, this is actually not so bad.
Yeah. It's I spent a lot of time writing my own like cheat sheet on operators and stuff.
Yep.
Okay. I spent longer on that than I intended to. So let's see. The next one that we wanted to talk about, this is one that you highlighted to me. Like I saw some noise about it, but I hadn't actually gone and read this thing until you pointed it out. I don't know if you want to highlight anything here.
Yeah, it really kind of like it lines up with what we were talking about last week with trying to restore etcd from a backup, but like Reddit on the 14th. I think we even mentioned this vaguely or a little bit early last week too about Reddit being down at some point.
Mm-hmm.
Well, their Kubernetes cluster, they went to upgrade it, and during the upgrade, they had a catastrophic failure essentially, and they posted their entire postmortem online as a subreddit, and it is amazing. Like it's very detailed. It's a good read. There's a lot of humor in it, and the gist of it is that one of the core problems is when the labels changed from say master to control plane,
Mm-hmm.
they didn't catch it, and so the machines were trying to deploy. They're trying to deploy into certain things. They thought it was Calico at first, but they figured out that Calico was working, and then when they saw the logs, like, oh snap, it's trying to hit a label that doesn't exist, but they'd already restored at that point. So it just goes to show that like upgrades are difficult on any platform, and trying to roll back and downgrade, it's not always let's do it.
Yeah, I don't know if I hope it's big enough that folks can read this here. Let me make it a little bit bigger. I highlighted this particular sentence here because as soon as I read that sentence, I knew immediately what the issue was.
Mm-hmm.
Right, like you said. So, and you can see it down here, right? Node selector has node role Kubernetes master. So Kubernetes 1.24 was when Kubernetes removed the master label and added or changed it to control-plane. And so basically all of this, their whole outage happened because yes, they're using Calico and all this other stuff, but the way that it was set up was it was looking for that specific label in order to deploy some configuration. And after the update, the control plane node went down, it came back up, it had the different labels, and then it didn't redeploy that bit of infrastructure, which in this case happened to be the Calico route reflectors, and it caused the cluster to, basically stop functioning. So I thought it was really, really fascinating for a couple of different reasons. One, as they mentioned up here, somewhere up towards the top, there's a really good sentence in here that highlights that, like here, Kubernetes has no supported downgrade procedure. So, we've heard for years and years and years, customers ask Red Hat, hey, can I just roll back my OpenShift cluster, if something goes wrong? And we've always said, it's a fail forward model.
Mm-hmm.
And it's not just us, right? It's the way that Kubernetes works. There's a lot of things that happen in an update that change, in many different ways, things like schemas and APIs and right, all of this other stuff that can, affect that cluster. So it's hard to roll back. We looked at it last week doing the etcd restore. And, in that case, it was different because we were trying to restore it onto a completely different cluster. But you saw the complexity associated with that, and they even walk through this process in the
Exactly.
blog
I was going to call that out. Yeah.
Yeah, they talk about how exactly like what we did, last week. It's I break the cluster. I take 2 control plane nodes down. I reform etcd as a single node etcd to then restore that state back, and then reform the quorum, at the however many etcd nodes I have, and let it sync and hope for the best. So it was definitely, I don't know if coincidental, serendipitous, take your pick, but it was an interesting one. The other thing that struck me as interesting is the deprecation of that tag, master, on the control plane nodes was announced in 1.20, Kubernetes 1.20, which was released in December of 2020. 1.24 was released almost 2.5 years later. It was released in May of 2022. So is 2.5 years enough time to test, to accommodate for something like this? I don't know the answer to that. In the grand scheme of things, it doesn't feel like changing a simple low label would have that big of an impact. But on the other hand, clearly some people were thinking about it, because if you look inside of like OpenShift, where's my cluster here? So right now I'm running 4.12. 4.12 is it 1.24 based? I think it is.
It's 25. It's 25.
1.25 based. So OpenShift is past that moment in Kubernetes time frame where it changed. But if I come down here to my nodes, you'll notice that we have both roles, right? We have both master and control plane. And if I click on my node here and look at YAML, you'll see there's labels for both that are in here. So control plane and master. So clearly somebody inside of Red Hat was thinking of this. And I don't know if we'll ever remove that. I haven't looked at any of the deprecation notices or anything like that for OpenShift. But it feels like one of those things of, hey, maybe we should use this Reddit experience, or learn from Reddit's mistakes, if you will, and take that into account as another thing. But yeah, it's one of those things that it feels so small.
Yeah. And the awesome part is that they were so transparent about it. I think GitLab a couple years ago, they had a big issue where, they were down hard, and they live streamed their their recovery, and then they wrote an awesome postmortem. Like, I think it's excellent when companies write postmortems like this, because then you can see, to your point, this was a tiny mistake, right? Or tiny thing to overlook, and just the scaled effect that it had. It's good for people to understand. Like, it's not always the big things. Sometimes it's the little things.
Yeah. Well, on the other hand, if you again, if you read through this postmortem, one of the things that they admit to somewhere up here is like their production and their test environments weren't the same. They walk through this whole thing of, years ago they implemented, and sorry, I'm scrolling randomly here as though it's going to help me find where I was going. But they implemented this production cluster years ago, and they use Calico. They used Calico correctly. They followed all of Calico's best practices, done all these things. As their cluster scaled out, Calico by default creates a mesh where every node is connected to every node, and it has to propagate those out. Well, as you grow the cluster size, to hundreds of nodes, that just simply becomes too unwieldy to manage, and it can affect performance and a number of other things. So the recommendation from Calico, which is exactly what they did, is to set up route reflectors. So that way the routing table is shrunk, right? You can avoid those issues. And again, they walk through this in here of, the logical choice was control plane nodes, because you're always going to have control plane nodes in a cluster that dynamically scales up and down. So they should hold those route reflectors. So absolutely, it makes sense in that respect.
Mm-hmm.
The problem was the original ops team is gone. Just natural attrition, people taking other jobs, like, all of these other things. So that the current ops team didn't know about it. And it's just one of those, like, production and test didn't look like each other. It feels like one of those, I saw somebody in the comments somewhere, they use the term haunted. If you don't know exactly what's in the cluster, should you treat it as haunted because you don't know what might happen? And, should you focus on, should you push on, should you use this as a learning experience of, no, we need to like authoritatively understand all of our configuration. Again, going back to last week's conversation and all of the other conversations we've had around disaster recovery and GitOps and all of this, of clusters should be disposable. And we should be able to recreate them one for one, not just for disaster recovery, but for things like this. Kubernetes has so many moving parts, so many components, so many things happening, and OpenShift adds a whole nother, basically, an exponential, order of magnitude. That's the phrase
Yeah.
I'm looking for, right? Additional, more complexity. So I thought it was, anyways, I just thought that was super interesting in a number of different ways. So
yeah, I'm really like bravo to those guys because they got through it and they got everything back up and running. But I really, just from a nerd perspective, right? Like I love the transparency. I think it's awesome, and it gives you insight into how people think and how they're troubleshooting and stuff like that. And like I will, and they really did. They thought of almost everything, right? I mean, like the fact that they caught that one little label at the end, like that sucks that they caught it late. It would have been cool if they could have caught it in the middle and then restored or gotten up and running. But
yeah,
I think it's awesome.
Yeah, it goes to the what do they say down here? Like 3.9 billion lines of log lines in their thing.
Oh yeah.
So it's a lot of logs. It's again one of those things that you don't think about until you have massive scale. Like, I can only imagine Reddit. Reddit's a top 5 internet site, I think. So how do you accommodate that scale? Waleed, interesting. How would SREs managed OpenShift scale the control plane? So that's an interesting one. And there's a couple of things that are changing in that respect. So one, from what I understand, we had, why are names escaping me today, Johnny? Get up, Sky to the Galaxy. Why can I not remember her name?
Harriet?
No.
Hillary,
thank you. She's going to send me a murderous email, and deservedly so. Hillary. So, Hillary worked on that team, I think still works adjacent to that team of like everything is very strictly, GitOps controlled. Like they have, very, very strict discipline about how they interact with the clusters, how they change things in the clusters and all this other stuff. And I think that's part of it is before they update, before they touch any customer cluster, they have very rigorous testing plans and they verify that all of their clusters match this configuration, and they tested those configurations. I feel like I'm speaking for them, but
it was interesting, right? I mean, like they were, if you like messed up, like there was like, it wasn't just like, oh my bad. It was like it was a thing. Like you had to sit down, you had to explain what you had to do, like or what you did and why you did it. I mean, it's serious.
Yeah, and also, so I alluded to some things changing. So we announced, and now I don't know where the announcement is, but the external public early access of hosted control planes with Rosa. So hosted control planes, of course, we've talked about here on the live stream, where you're putting all of the control plane services, all of those pods that make up the control plane, you're hosting them in a different cluster with the compute nodes, the worker nodes for the cluster being separate. So that'll certainly change how all of that works and how they control and manage those things. I haven't fully digested how that impacts disaster recovery. In theory, your control plane is now, it's a set of pods, which it always has been, but they're using things like PVCs. etcd's data is now stored on a PVC, and it's abstracted from the underlying cluster. So if your hosting cluster were to be affected, you can simply restore those pods to a different cluster, redeploy them on a different cluster with the same PVC data, and it would come back, as long as you can point the route back at them. So
I was trying to find the announcement. I found like the internal one.
Yeah, ChatGPT. Yeah, ChatGPT. So, Johnny, you were at Tech Exchange, and we were talking about Ansible wisdom, and Craig was the person doing the presentation during the keynote. He was talking about how ChatGPT is really, really awesome, but it doesn't know when it's wrong. So it has these very authoritative sounding, matter of fact, like this is the right thing, and it has no clue that no, that isn't right at all. And it's funny because I've seen a number of internal messages recently about like, hey, I was trying, I asked ChatGPT this and it said that I could do this. And one of them was like including some security information or something like that in the install config.yaml. It's like, no, clearly that isn't there. But ChatGPT was like, oh yeah, absolutely. Drop this YAML in install config and it'll deploy these things in your cluster and you're good to go. And I'm like, oh yeah. So
Get a little digital fist bump.
Yeah. So I am curious to see how it will help over time. I do, definitely having an inkling of an idea we're going to be showing during the keynotes and stuff at Summit this year. Keep an eye on what's happening with Wisdom. There's some really cool stuff that's happening inside of there. And I hope to someday that we can have the Wisdom folks on here so that we can talk about a lot of the behind the scenes stuff and how they operate and how they train their models and all this other stuff, because there's some really awesome stuff there.
Yeah, that would be super nerd.
If nothing else, I think we broadcast the keynotes out to the world. You don't have to be a registered attendee even, I don't think. So watch at a minimum the tech keynote, which is I think day 2 this year. Waleed, if you're not familiar, Ansible Wisdom is so we announced it back at Ansible Fest last year. There's some videos that are available on, I think, the Ansible YouTube channel.
I'm getting them right now.
Effectively, it is a machine learning / AI thing that allows you to quickly and easily create Ansible playbooks. So the demos that they show are effectively, you go in, you create a new playbook, using your IDE editor, and you create, basically you give it a name, create a new virtual machine in Azure, and the machine learning model basically spits out the Ansible playbook, the Ansible YAML that you need in order to do that. And then, okay, me, the human, I review it, I make sure that it is, it has what I need into it. So next step is, now create a new Azure network. Now connect my VM, and you just step through this, basically naming your steps, and it takes what it infers from the name to actually make that happen. So it's really cool. There's a lot of really cool things that I think can happen there with the with that Wisdom, the ML model. But like I said, keep an eye on Summit and the keynotes that we'll have there. All right. Let's see. We had one or two others, but in the interest of time, I'm gonna move on, because this has been. I appreciate the conversation, everyone. This has been really great. Ops is fun to me, and seeing what happens inside of one of the biggest websites and literally in the world is always interesting to me.
Yeah, same.
I'll quickly. I said that with the last one. I'll quickly cover this one because I got the tab open. So somebody asked this week about I think they misinterpreted this segment of the documentation. Let me post this. When you look at this, what it says is, if you're using VXLAN, then there are a number of reasons that effectively pod-to-pod communications become limited to approximately 1 gigabit per second. So even though the host may have 10 or 40 or 100 gigabit whatever networking, pod-to-pod communications get limited by the tunnel, by the encapsulation, and various things that happen inside of there. I think one of the vacuum trucks is going through the neighborhood. I hear this very loud buzzing. I don't know if it's coming through the microphone, but
I can't hear it.
Yeah, they the city sends, people dump their yard grass trimming, all that on the next to the road, and they come through and vacuum it up. Anyways, so yeah. Anyways, the end result is, yes, at least it appears according to the documentation here, that if you're using VXLAN, which OpenShift SDN uses VXLAN, pod-to-pod communications might be limited to 1 gigabit per second. That being said, I've asked for some clarification and some additional details on this, because I've also seen performance testing that shows far more than 1 gigabit being possible. So I don't know if this is just based on outdated information. I mean, here, let's roll all the way back. Well, page doesn't exist. Okay, so how far back does this page go? Yeah, so at least in 4.4, which 4.4, keep in mind, was 2.5 plus years ago, 3 plus years ago. Like, a lot's changed. So, maybe something is different here. Maybe there's something else. But I've asked for clarification here. If you think that this is an issue, or if you think that you're encountering this, there's a couple of different ways you can work around it, for lack of a better term. One is to use Multis and connect the pod to a secondary network. one that isn't, maybe it's directly connected to the outside world or something like that. Two, you can use OVN Kubernetes. OVN Kubernetes is, of course, OVN based, which uses Geneve. Geneve. And you can do an update, online update from OpenShift SDN to OVN Kubernetes. So somewhere up in here in the docs under networking, OVN Kubernetes, migrating from the OpenShift SDN. So you can see here that it walks you through exactly how to upgrade, how to transition. I don't know if it's an upgrade. It depends on your perspective, I guess. And this has been in place for a long time, like maybe 4.8. Yeah. I think 4.8 was the first version that OVN Kubernetes was fully supported. So it's been in there for a long time. So you can absolutely do that update if you so choose. The other one would be to use a third party, a different SDN. Cisco ACI, uses, I don't know if that it uses an encapsulation so much as it just connects directly to the upstream switches and does whatever it does. Calico, of course. Calico, I think it operates at layer 3 and uses routing instead of encapsulation. There's a number of others that are out there that use all different protocols. So, all right. I'm just catching up on chat just to make sure I didn't miss anything. All right, that was all I had. So let's which one do you want to cover first, Johnny? Control plane machine sets or infra nodes?
Let's go with control plane machine sets.
All right. Not just because that's the tab I have open, right?
Oh, actually, I didn't even see that, to be honest. So.
Let me share this page of the documentation here in chat. So this is, I think we said before, this is a feature capability that was added in 4.12. There's a couple of interesting, or a couple of important things I should say to know about it. One, it is only supported with a subset of cloud providers. So you can see AWS, Azure, and vSphere. So if you're deploying to other platforms, regardless of whether you used a UPI or an IPI deployment or anything like that, it does require cloud provider machine API integration. So non-integrated clusters it wouldn't work with. But regardless of that, you do need to be on one of the supported cloud providers. The other thing to note here is only with AWS is it activated by default. Meaning as soon as you deploy the cluster, right, as soon as OpenShift install is done running, only with AWS do you have a control plane machine set in place. With Azure and vSphere, the administrator, have to go in and basically turn it on. You have to create an instance of the CR, the custom resource. So you can see this docs page kind of goes through and explains all of that. Here creating a control plane set custom resource. So if you're using Azure or vSphere, this is what you would need to create, more or less. AWS, as we'll see in just a moment, it's there by default. So what I wanted to go through today is going through this, managing control plane machines with the machine set operator. And there's a couple of different things that I wanted to look at. So the first one, and I actually didn't notice this, Johnny pointed this out, and that is the rollout strategy. And I don't know where it's at. Anyways, we'll look at it in the YAML in just a moment.
Yeah.
So what I think happens is, so with a traditional machine set, if I go and make a modification to that machine set, nothing happens until I deploy a new machine from that machine set. And then it will have whatever the new config is. It doesn't go back and retroactively change the configuration of the existing machines. So let's pick on, here, I'll come over to my cluster here. So in my cluster here, I've got a number of different machines. And from a compute perspective, I only have one machine set. You can see it's in US East 2C. And if I were to come in here and, for example, modify this instance type, it doesn't change anything until I deploy a new machine. And then it would use that new machine's instance type. What I think the rollout strategy means, in particular when you use the rolling upgrade strategy, I think that means that it will go back for control plane machines and basically ensure that they match whatever's in our config. So we're going to test that a little bit here. So the first thing that we want to do is come down here to our custom resource definitions. So you'll notice here in compute, there is no navigation item, I guess, menu item here for control plane machine sets. The CRD we find by searching here for control plane. And we have this control plane machine set. And if I switch over to instances, I have one control plane machine set instance named cluster. And if I browse our YAML here, there's some interesting things that we can see about this particular object. So one, 3 replicas, of course, we want to have 3 control plane nodes. So here's that update strategy. So type rolling update. So I'm thinking, and we're going to find out in a minute, that this will cause it to automatically trigger a redeployment in the event of a change. And then because this is AWS, we have a number of failure domains that are defined here. So first, you'll notice that right now we only have US East 2C as the AZ that our control plane nodes are deployed to. So if I were to, I don't think no, oops. Yeah, I don't think that did I turn on my SSH thing? No, I didn't. So I can't SSH in and show you. But if we come up here to machines, we can see that they are all in US East 2C here for the availability zone.
And I'm just going to answer a question real quick, so that way it gets across. But Babuni had asked, can we scale up the control planes from say 3 to 5 using the control plane machine set? And in the docs, it clearly says that horizontal scaling of the control plane machine set is not supported. So it's still a maximum of 3 control plane nodes.
Yeah. Red Hat, I don't know. Surely somewhere there's like there someone has a support exception for more than 3. I have to guess. But by default, we only and always only support 3 control plane nodes, unless it's a single node OpenShift, and then there's one, of course.
Mm-hmm.
But yeah, I know, I am sure you could force it to happen. You could go in and you could modify all of the appropriate things. It may not even be that hard. It may even be just changing the number and it does it itself.
It just goes, yeah.
but technically that still wouldn't be supported, right? We only
Mhm.
support 3. I'm curious. I should go and look at the roadmap because I've heard rumblings of various things that don't change the number of etcd nodes, but affect other things when it comes to control plane. So I feel like I feel like we should probably have that product manager come on and talk about what might be happening there, if they can.
Got it. I took a note of that.
Yeah. Yeah. Thanks for the question, Babuni. So failure domains, AWS placement and availability zone, if I could speak, US East 2C. And then from here, it just kind of filters down, here it tells us what network it's going to use, that type of stuff. And then after that, it goes into just like any other machine set, kind of the labels and the other things that it's going to assign to our deployed nodes. So you can see here the spec, and here's the instance type that it's going to use, and the type of block device, the type of storage it's going to use for the virtual machine, and all the normal, AWS stuff that it needs for security groups and, all that stuff. So all the stuff that we need in here controlled via machine set, just like with any other thing. So what I want to test out here is what happens if I take this and I duplicate it for 2B. And what makes me curious as to whether or not this is actually going to work is I don't know that there's actually a network in 2B for it to connect to. So that could be interesting, but we'll see. And try this again. with 2A. Oops, not 2A. So I'm now less optimistic that this is going to work, but we'll see. Because I don't know that that network exists. Maybe it's smart. Maybe it'll do the right thing. But I guess we'll find out, right?
Yeah.
So, yeah. So to be clear, this cluster was provisioned in a different way than I normally provision them. This is not a default IPI install. This one was customized by the RHPDS folks. So they limited the cluster just to 2C. And I wonder if that will have any impact on us. So let's find out. Let's click save. So in theory, if that roll out strategy that we were looking at up here before, where'd you go? Anyways, if it is set to, or if it will take automatic action, then maybe what we're going to see here in a moment is our machines, being changed.
Yeah.
So it has already failed one of the control plane nodes. And I can only assume that
It's not working.
Yeah, so control plane, worker, control plane. So it hasn't removed the node from the cluster yet, but the machine has been failed. Am I logged into AWS? AWS console. I'm wondering if maybe I can actually look in AWS and see.
Oh, do they give you access to the console?
Oh, that's a good point. This isn't a normal account. This is through RHPDS. So I don't have access to the console.
The one thing that you could do if you wanted is change the machine size. So if you go back down into your, I've obviously stripped this stuff out, but
yeah, I'm afraid if I do too many things at the same time, it's gonna really break things. So
I gotcha.
Yeah. Let's see. So oh look, there is a new one. Oh wait, maybe that was the new one. Is it me or are those two names the same?
Yes, they look the same.
So maybe I.
Oh no,
maybe,
they're different. They're different. It's got a different GUID.
Oh yeah, it does. 868 versus Z8 Charlie. So, yeah, that'll be. Oh, let's see what happens here. Let's see events. Why are you failed? No subnet IDs were found. Well, that explains that. So our networking trick did not work here. Let's go back and let's just see. I don't think it can use the same subnet. You've got a cluster up. You can try this though, right?
Yeah.
So if nothing else, I'll just hand over to you and you can change the instance size and see what happens. What am I looking for? Control plane. Instances, cluster, YAML. So let's just change this. There's no way that's going to work. So let's look at, where's our documentation? Yeah, so they're saying here, things like changing the instance type. Load balancers, type network. Okay. Yeah. So that's interesting. I don't know how to get it to actually create one. Because even down here, it doesn't list out that information. So the good news is it did proactively begin to try and change the configuration. The other good news is you notice that it didn't preemptively destroy our existing control plane node. So our control plane, despite having made a change, despite having this failed machine over here, we still do have all three control plane nodes. So the control plane is fully protected. So that is, in my opinion, a good thing.
Yeah, I agree.
Wondering, I'm gonna try something here. Just take an extra 30 seconds. Oops, I want YAML view. And I'm just gonna do away with this filter and see what happens. Maybe it'll create one. Right. Save. Reload. Okay, so US East 2C, where we know we have a subnet, is going to use our existing subnet. Up here in machines, 011. Okay, so it hasn't changed anything up here. Delete. All right. Failed. Nope. So that's not going to work. Yeah, same thing. No subnet IDs. Okay. So that's interesting. Seems like there maybe, I'm sure that there's a step that I'm missing here, which is namely creating a subnet on that particular availability zone. So what I'm looking at over here is API MachineSet. Yeah. I wonder if we were to create a MachineSet, a worker node MachineSet over in that AZ first, if that would cause it or trigger it to do anything like that. But I don't know.
Yeah, I'm not sure.
Anyways, interesting rough edge to encounter. We should definitely double check with the PMs to see if there's an open RFE or something like that, or maybe I'm just missing something in there. But you want to take over the screen share just to show the changing like this instance size?
Yeah. Hold on just a second. Wait.
Yeah, R-Hope9, I agree. If I know some things will work. I knew I was pushing the boundaries with adding in the AZs, in particular with no other defined infrastructure in those AZs for this cluster. So I was hoping operator magic would save us, but that's not the case today.
Yep, no such luck.
Yeah.
So all I'm going to do here is just change the machine type. So we actually get this question all the time, right, Andrew? It's like,
yeah,
how do I change the machine size, or how do I change the type of my control plane node? And so I'm just going to go in here and I'm going to make that the old 2XL from an X large, and then I need to move my monitor so I can see my buttons. And save, and then reload.
Yeah, there's your new one already provisioning. Yep. So I think the other place where this is really, really helpful. So yeah, it's really cool to be able to make changes and things like the instance sizes and all that. So I see somebody mentioned in chat here adding machine health checks. So if your node fails for whatever reason, it will go in and will redeploy, right? It'll create a new node and rejoin it as a control plane node. So it's super helpful for those scenarios where something has happened, something has broken, and I need to, I need to reprotect my control plane. It's literally going in and just you don't even have to do anything, right? Delete the machine at worst, and it'll recreate it. Which you saw with that failed one that I did, right? It was failed. I went in and I deleted it. It immediately popped back in, trying to provision a new one, which also happened to fail. But if it were a regular node or a fully functioning node, machine health check would determine, hey, this is unhealthy, right? Once that gets marked as being unhealthy, the operator comes in and it removes it and it provisions a whole new one and reprotects the control plane automatically. I hope that there's some log messages about that, because I feel like that's something you would want to know about, but
exactly.
Surely there is.
The other thing I wanted to point out here too is that, like, if say, we always, maybe not so much anymore, but like a long time ago, it's like, how do you provision public and then you turn to private, right? So you build it using API without doing anything crazy, and then you essentially want to lock down your API access to only the internal subnet. Yeah. So something that you could do is you can just go in here in the same control plane machine config and remove this external load balancer entry from the list, and then that makes everything private. It'll redistribute all of the endpoints so that way they're all pointing to the private side, and it'll remove the external ones. I saw that in the docs. I was like, that is super awesome. Like, that right there is like, being able to change the machine type and then being able to essentially toggle on and off internal or external access, I think is amazing.
By the way, if you don't have access to that internal subnet, if you change that, you will lose access to the cluster
Yes.
until you gain access to that internal subnet.
Yeah. But make sure you have your VPN set up.
Yeah, or a Bastion node that you can hop onto.
All right, so let's go back over here to machines. I just wanted to point that out. Then the same thing goes back to like if you wanted to change your volume size, or even like your type or whatever, like all the things that you would do in a normal machine config, you can just go in here and make that change, and then it will, it'll make the change. It'll make the change and then redistribute. And then to Andrew's point earlier about the update type. So if you have your strategy as rolling update, it'll do it automatically. If you have it to what was the other one? On delete. Then you're forced to go in and delete the node and then let it rebuild.
Yeah, I think this is an interesting one too, especially on-prem. You think about vSphere, etcd performance is always a big deal, and we don't support storage vMotion. So this is one way where you can go in and you can basically say, put this on a different data store, and it will go in and move those around. I don't think so with 4.12 we have tech preview support for quote unquote zones in vSphere. I don't think that is supported by this yet, because it's not supported by the broader OpenShift yet. Again, tech preview. But I'm curious to know whether or not those two things work together. So can I, for example, tell it to deploy my control plane nodes across multiple vSphere zones, quote unquote, and see what happens there. In particular, we don't create, we've talked about this recently on the stream here, right? We don't create the MachineSet or machine API provisioner doesn't create affinity or anti-affinity rules for any OpenShift VMs in vSphere. So I can see how, depending on how your zone configuration is inside of that vSphere environment that you're using, again, tech preview in 4.12, but you're using that zone feature, how you could basically mimic that type of setup, at least at deployment time. Because there's nothing that forces you to have those zone definitions, I don't think, on like a data center or a DRS cluster. I think you can put them on individual hosts. So you could force it maybe that way to deploy across multiple hosts. Of course, vMotion can still happen, and you can still end up with them all jumbled up, but it might be one way of doing that, or at a minimum deploying across different DRS clusters in the same data center. Private side. Yeah, so we can see like the node, it got deleted as soon as another control plane had come up. So the existing, control plane 0, it's gone. Or it's on its way to being gone, and the old one or the new one is here. And so if we take a look, we should be able to see. I really like that it waits to delete the existing one.
Yeah.
Do keep in mind one thing, just from a pragmatic approach. If you're going back to the etcd performance thing, if your etcd is kind of at the threshold of performance, where it's already having issues, read, write, etc. If you aren't careful, cognizant about the time that you're doing that, it can cause extra stress on that. So what I mean by that is, I've got my 3 etcd nodes, or my 3 control plane nodes. etcd is having some latency issues. And so, oh no, I need to fix this. Let me go in and let me change the data store that it's using. And it begins redeploying those etcd nodes, or control plane nodes. When it does that, the existing etcd nodes have to populate the new etcd, which is going to cause a influx or a surge in read activity from that source etcd. Or those source etcd nodes. So just keep in mind that you can inadvertently affect things like that. It might only be a little bit of data, but most etcd databases aren't like tens or hundreds of gigabytes, so it might not be a lot of data. But etcd being what it is, being sensitive the way that it is, latency sensitive, could be an issue. All right. So any questions around that, feel free to ask those in the chat here. It's, again, we keep adding these things that on the surface are amazingly simple, right? You went in and you changed one thing, and now it's redeploying the control plane, which is a massively complex thing, as we saw last week, of And we also demoed before, how to replace a failed control plane node. It took us over an hour to walk through all of those steps in order to regain. And I think I even failed because I had 2 DHCP servers. I think that it was that stream. Whereas this, so long as you're on a supported infrastructure, right, it doesn't get much easier than that. Abstracting the complexity away. So I really like this one. I'm so happy to see this feature being available, and I'm excited to see it, over time grow to more infrastructure types as well.
Yeah, I agree, man. I just messing with it this morning and looking at it, I'm like, dude, it's so easy, and I think that's where a lot of times we kind of like, I don't want to say for everything, but we miss the mark sometimes, right? Where it's like we make this really awesome thing, but we make it kind of difficult to use. This is just straight up simple. Like, hey, if you're in AWS, we've already set it up for you. Here's the CR if you want to do it anywhere else. Well, in Azure and vSphere. But literally, like, if you just want to make a change that you would normally make, boom, go ahead and do it and let it roll it out. Like, I think that's so awesome.
This does make me wonder if we're going to add, that rollout strategy type of thing to regular machine sets.
Oh yeah, that'd be cool.
So yeah,
I'm going to do one thing just to we can do it behind the scenes, but now I got to know. I'm gonna bump it up to 5 and see what happens.
I like where your head's at.
Yeah, that's a hard no.
I mean, I guess that's good to know. It won't let you, willingly put yourself into an unsupported position.
Yep. There we go. We found out first.
So validating webhooks for the win, right?
That's right. All right, I'm gonna stop sharing.
All right. So the second thing we wanted to talk about today is infrastructure nodes. So I'll reshare this guy. So I did go in here just to show everybody. I just went in and removed. I know I'm looking at a regular machine set. Here we go. So I just went in and removed the stuff that we added. So we're back to normal on this one. And you'll notice that it also, as soon as I did that, it also cleaned up that failed machine. So that's kind of cool. Anyways, so we're going to talk about infra nodes. So infra nodes are something that were first. I don't know that other Kubernetes had the concept of an infra node before OpenShift, but I first became familiar with them back in the OpenShift 3 days. OpenShift 3, I believe they were required.
Yes.
You always had control plane, infra, and compute or worker nodes. With OpenShift 4, they became optional. And infra nodes are useful for a number of different reasons. Not the least of which I always like to point out is the entitlements for them are included. So just like with control plane nodes, you don't have to use any of your entitlements with infra nodes or control plane nodes, only for your worker nodes, which means that it's a great way, particularly once you start adding, layered features, functionality of OpenShift to save on those resources. So for example, logging service, metric service, right? All of these things that would normally get deployed onto a compute node can instead be moved over to a infrastructure node. So I'm going to look for, I don't want operators. I want cluster operators. So, we can come down here to, for example, the metrics monitoring side of things, right? And effectively what we would do is eventually, or what we will do eventually, is set these so that they are deployed onto our infra nodes as opposed to now where they're deployed onto our compute nodes. And I think I can come here and search for yes. The wrong project, that's why. So you see we have all of these different Prometheus pods, and without an infra node, they just get deployed wherever they get deployed. So that's the goal, is we want to create infra nodes that we can deploy infra workloads to. So you may be asking, what qualifies as an infra workload? So one, if we look in the documentation here, it will help us walk through some of those things that qualify. Following infrastructure workloads do not need or do not require worker subscriptions. So you can see the router ingress, right? The integrated registry, let's see, Quay, ODF, ACM, ACS, OpenShift GitOps pipelines. There's also in the subscription guide, that link. So the subscription guide also details a number of things that encompass worker node or infra nodes. So if I scroll all the way down here, by the way, we're changing the name of this, assuming my change request gets approved. We're removing sizing from the title of this because this doesn't talk about the sizing of an OpenShift cluster. Rather, it gives an example of the size, quote unquote, of your entitlement pool based on your cluster layout. So in order to avoid confusion, I put in a request that we change or remove sizing from it.
And Fahad has a question real quick, if you don't mind. Can we utilize infra nodes for non-Red Hat workloads?
Usually not. I say that because here we go, infrastructure nodes. I say that because let's pick on, I don't know, pick on some third party, one of our partners who provides, say, a registry. So the integrated OpenShift registry as well as Quay can both be hosted as infrastructure workloads. But a third party, even our partners, their registry product would not be considered a part of that infra workload. However, some things like a CSI driver are considered infra workload. So for example, if you use, I'll pick on NetApp, Trident. If you deploy Trident is considered part of that infra. The definition is a little bit fuzzy for my taste. I'm a very precise language person. But you can always ask your account team. There's ways that they have of escalating back to the BU, back to the folks who manage these things to get confirmation if you have any questions about it. So you can see here examples of non-Red Hat software that qualifies infrastructure include custom and third party. I'll highlight here monitoring agents. So again, to use an example from our partner ecosystem, Datadog. The Datadog agent can be deployed across infra and control plane nodes, and it doesn't disqualify them from having the entitlement exception. CSI drivers, CNI interfaces, hardware virtualization enablement accelerators, which is a weird phrase. I'm pretty sure that's referring to things like the NVIDIA operator and deploying, the stuff that it needs for managing GPUs and all that. Controller pods used for Kubernetes CRD are operators, custom or third-party software. So this is going back to like NetApp Trident. So Trident is both an operator that it uses to manage itself, as well as a daemon set that deploys pods across all the nodes. So kind of those two things mean that it is qualified as an infrastructure workload. So yeah, I would say definitely, you can reach out to your account team. They're the ones who will be able to give like specific guidance, or reach out to the right folks to get authoritative answers for anything that you have questions on there.
Yeah, that's what I was going to say. Like he asked about like an Nginx ingress controller as an example. In my mind, I'm like, that makes sense that would be on the infra node as a controller. But yeah, definitely reach out to your account team and let them go fight the fight for you. Make sure that it's supported before you.
Yeah, and there's other things like let's see, there was one down here about RHEL entitlements as well. Like, yeah, Red Hat Enterprise Linux entitlements for supporting services. So in the case of, let's say you deploy UPI, you want to use HA proxy or Nginx or whatever, deploy it onto a RHEL VM, or a RHEL node as the load balancer that sends traffic into your cluster. Well, that isn't included in OpenShift entitlements either. You can see from this paragraph that the only RHEL entitlement that's included is a node for bare metal API provisioning. However, and just because, it's semi-legalese just to make these things more complicated, if you deploy VMs using OpenShift virtualization, RHEL entitlements are included for those virtual machines. So if I'm deploying vSphere UPI, I cannot use OpenShift entitlements for another VM hosted in vSphere to act as the load balancer, or host HA or HA proxy Nginx, whatever, for my cluster. But if I'm deploying into OpenShift virtualization, that RHEL entitlement is included. So slightly confusing. And that OpenShift virtualization thing, I think there's a blurb like way on up here. Quay Data Foundation. There's a blurb way up here about, here. This includes the entitlement to use Red Hat Enterprise Linux as the guest operating system in the virtual machines hosted on OpenShift. So it's very explicit about, for VMs hosted in OpenShift using OpenShift virtualization, RHEL entitlements are included, which is really cool.
That is cool.
Repress the most important OpenShift 3 node type, the Bastion. Was that an official node type? I always just had one. I don't remember. You had to have an Ansible host to go in.
It was the unspoken law,
Yeah. How do subscriptions work when do auto scaling and spot instances? I don't know how often it is adjusted. My understanding is that the pool should be large enough to accommodate your surge capacity. But clearly we do on-demand licensing, or entitlements rather, for things like, ROSA and ARO. So I would definitely ask your account team about that, Waleed, of whether or not there is a way that you can do sort of on-demand entitlement pools for, your on-prem clusters, stuff like that. If you put no Red Hat workload on Infra nodes, you have to license the CPUs. I'm not sure about that, or Hope9. So, if you put your workload, your applications on there, you have to license either by socket or by core, depending on the node type. But I'm not sure what you mean there. Is it adjusted monthly? I'm rereading the second part when I saw our Hopes9 comment there about great question of your question, Waleed, just to make sure I answered everything. Subscription, I think it's called Subscription Watch, Johnny.
I think so.
Thing? Yeah, it's part of the normal infrastructure that we use for RHEL and everything else of reporting, subscription and entitlement utilization. I don't know how frequently it gets updated or how frequently it reports in. Even then, clearly it works with disconnected clusters. So I would assume at some point it becomes I hate to say this, an honor system.
Yes, on the disconnected side it is. I didn't want to say it, but yeah, it is. Talk to your account team though, right? Because they do have ways to account for bursting, right? Because we back in the day, we had a customer that was using AWS, and they had similar concerns. Like, I'll run skeleton crew as much as I can, and then when I have demand, I want to burst up, and then essentially I'll pay for my CPUs that I'm using then. And they worked something out. I don't remember all the details, but it's something that can definitely be flexed.
Yeah, our Hope9 asks an interesting question. So if you have deployed OpenShift on hardware and you're using OpenShift virtualization to then deploy hosted OpenShift clusters, how are the entitlements used then? So if the physical OpenShift cluster is only running tenant or hosted OpenShift clusters, you don't have to entitle that cluster. If you run other workloads, so if you're deploying other non-OpenShift VMs in there, if you're deploying other, containers, pods that aren't, they're doing other things, then you would have to entitle using socket entitlements those nodes. So you entitle, in that scenario, you would entitle the cores for the virtual clusters. So there is I've seen some chatter about that, and narrowing those rules down, particularly in light of hosted control planes. So they are working on a hosted control plane provider for OpenShift virtualization. And that might change that calculus a little bit. So I'm hoping that we can learn more as we get closer to that being a reality, but that's later this year before we'll really know any more about that. But yeah, today you can absolutely deploy OpenShift clusters using OpenShift virtualization to a physical OpenShift cluster, but it is a non-integrated install, and you have to entitle those nodes using core-based entitlements, those virtual nodes using core-based entitlements.
Right. There's one more question from Babuni. Can we use one IP for API and ingress for API cluster installations? So a single IP for both.
I don't think so, because they're managed by Keep Alive D, and the API IP will always be on a control plane node, and the ingress or start out apps IP will always be on a node that hosts an ingress controller, which is usually going to be either a standard worker or an infra node, but it could be a control plane node as well. Yeah, there's no, if you look at that, there's no magic that's happening there. It's not like a traditional load balancer where you can say, oh, if it comes in on this port, which is exactly what we do. Here, I'll bring up, we'll look at the documentation here. Installing on any platform. So it gives somewhere in here, I think, I remember there being a sample, come on, load balancer config. No, did we pull it out? There it is. So in here, it basically says, if it comes in on port 6443, always send it to these nodes. If it comes in on 22623, send it to these nodes. 443, send it to these nodes. There's nothing, no actual load balancer behind those. It's just a virtual IP that is hosted on a node that has the right ingress for it to be able to access that traffic type. And that's just how it functions. So I wish it was a little smarter. It would make a lot of things easier.
Mm-hmm.
Okay. So keep questions coming in, y'all. Thank you. So let's switch back over to our infrastructure stuff over here. So creating machine sets is really straightforward. So I'll point out two different things here. So one, you can create these using, if you're on a infrastructure that has machine API integration, you can create machine sets in order to manage your infra nodes, just like with compute nodes. If you're not, or even if you are, you can still provision them manually. So the difference is with a machine set, the labels assigned to the nodes are managed by the machine set. So when it creates that node, it, as we can see here, it assigns all of those things to it. Whereas without a machine set, you're simply adding a label to the node. And that is, you can see here, the label that we associate with it. So step two, and I think it gets down here. Creating infrastructure node. Here it's just saying label the node. And then there's also a step that we take later on that applies a taint. So I don't know if it's in this. Yeah. Finding infrastructure node workloads using taints and tolerations. So remember, if we host, application workload on our infrastructure node, it disqualifies it from that subscription exception. So we use a taint to repel other workload from that node. And then we have to go in, and that's why there's this whole section in the documentation here about we have to go in and we have to add the toleration to the specific workload that we want to go onto that node. So it walks through down here and it goes, here's how to move the router, the ingress controller over to our infrastructure node. So I want to quickly attempt to create an infrastructure machine set here. And I thought that there was, there's compute machine sets. I thought that there was one that explicitly, here's how to do it on AWS, but I guess not. Yeah, here's vSphere. So what I'm going to do is instead, where'd my node go? I'm going to copy out one of my, or I say one of, my only machine set. We'll go up here and hit the plus sign and get rid of a bunch of junk in here. Don't need.
This is actually exactly how I do it, by the way.
Yeah. We don't need any of that. Need any of that, do we? Yeah, we need the API version. That seems. Oh no, that's all still part of the managed fields thing. All right, get out of here. So that we need. We don't need this. We don't need the annotations. We do need these things. That are two, and yeah, I know I need to change a bunch of other things in here too. All of that can stay. All of that can stay. Sure, we'll keep all the tags. And we can get rid of the status. Right. So now I think we're down to the minimum or the actual fields that we need here. So the first thing we want to do is change this, basically any instance of the word worker to infra. Data secret. We'll keep that worker user data secret.
Yep.
I think that needs to stay. Security groups. Yeah, we'll keep our security group there. AWS machine provider config. Yep, all the tags are fine.
Yeah, you really should only have to change the labels.
Yeah. IAM instance profile. Yep, we'll keep the same IAM instance profile. So yeah, the main thing is it's literally just like any other worker node. We're just changing the label that's associated with it. And then our instance type, I don't think we need a 4x large just for this. We'll double. And we'll hit create. So we now have our two machine sets that are running inside of here. Hopefully, if we come over here to machines, we see our two new machines that are getting created. And if I come here to the machines, look at the YAML, so you can see here's our labels. Eventually, once they get provisioned and join the cluster, they'll show up as nodes that will have an appropriate label or a role assigned to them inside of here. So a couple of things to note. So getting to this point, as you saw, relatively straightforward. But remember that the machine configuration is managed through, as you might have predicted, through machine configs and machine config pools. So there's some debate, it's kind of a preference thing on whether or not you want to have a separate machine config pool. Wow, that was I just, I cannot talk. Machine config pool, for your infrastructure nodes. I am of the opinion that you do want to have a separate machine config pool for infra nodes. I say that for two different reasons. One, there is probably some specific config that you want to use on those. Maybe that's a different set of SSH keys so that only a subset of administrators can access those nodes, just like with control plane. Maybe it's I don't know, any one of 100 things that you could think of inside of there. The other reason is because updates are applied at the machine config pool level. So when I go and trigger a cluster update, it will roll that out to all of the machine config pools simultaneously. So that means that I can do things like pause just the infra nodes or just let the infra nodes update, control plane and infra update, for example, if I'm doing a fast forward, while letting the compute nodes do their thing, whether that's to have them be paused or have them to move forward. So I think that you would want to do it for those reasons, but completely up to you and your preference for how you manage things and all that type of stuff on having the machine config pool specifically for infra workloads. The other thing is with the machine set, we can scale those independently. So you may end up in a scenario where you have maybe a bunch of infra nodes, or conversely, a few infra nodes and a lot of compute nodes. And if they're all in one pool and you're doing one node update at a time, which is the default for a machine config pool, it can take a very long time comparatively. And maybe you want that to happen faster. You want these infra nodes to update faster. All right, our machines are already up and running. So our nodes should be joining here shortly after they do their thing. Yeah, here's the 2. So it only has a worker label right now. I assume that'll get fixed.
Yeah, you actually have to label them. I messed with this for a little while. I was like, I don't know why. I tried adding like the actual Kubernetes role inside of the
Is it?
machine set.
I thought it applied here. But yeah, you may be right.
But yeah, for the machine config pool, I didn't even think about that as far as like having a different SSH key. That's a good idea, actually. I like that a lot.
So, all right. So our nodes are already ready. Wow, that happened fast.
Mm-hmm.
I feel like it happened fast anyways. So let's look at our YAML here. Here we can see our machine infra. So now we need to go in and we need to, you know what it is? I bet I didn't add the right thing. I bet I skipped. There was probably a step up here. Yeah. Roll and type. I bet I did not set those correctly because I was in a rush. Oh no, roll and type are both set to infra. Did I miss anything else? Taints. Yeah, so that's where you set the taint at.
Mm-hmm.
See, this is what happens when I get in a rush. So the taint is important. We do want to make sure that we have that. So I should probably add that on there. Where did that go? That was underneath the spec. Thanks, Johnny.
Yeah, I didn't even see it, honestly.
Keep me honest on these things. Jeez. That's why we can't have nice things. Never a dull moment.
It's always something, right?
Yeah. Yep. See, it's not just you that does things, gets in a rush and does things.
I know. Well, and then when you're rushing and you're trying to slow down, it just makes it worse, you know?
Yeah, machine set, okay. Machine set, okay. All right. So let's save that. And yeah, see, there's no rollout strategy here. So it doesn't actually go back and change those like we just saw with the control plane nodes. All right. Where's our nodes? 5 and 5. There we go. Double X. Marking them this way more just to get them out of the way. And then I want machine sets, and we're going to scale this down to 0.
This is by far my favorite feature of OpenShift 4. Without a doubt, hands down, like the machine set, being able to scale them up and down by pods, I think it's so awesome.
And now we got 2 more coming in. All right. Anyways, so that way our taint will automatically be applied. When the machines get provisioned, we don't have to worry about going in and adding it in later. You can add it in later. Just be aware that as you modify the machines, as we just saw, it wouldn't be reapplied without having it in the machine set. So we'll let that do its thing. Kind of at this point, really what I wanted to do is show, like down here, moving some of this workload. So a couple of other things to consider. There's nothing that says that you don't have to, or that you have to have only a single infra node type. So it's perfectly valid. For example, like, hey, I know I've got this application that has just incredibly massive amounts of ingress that's happening, or even ingress, because you can, use egress IPs, and you can put an egress IP onto an infra node. So my application does all of its ingress egress, and there's huge amounts of this, and I want to pin that to a specific node type. So you can absolutely create your node, give it the infra label, give it another, node label, node annotation, something like that, that says, application Y ingress or application Y network or whatever. And then, effectively take your ingress controllers and just like we see here, go through and modify it. Go through and modify it so that your ingress controllers for that application land on that node and nothing else does, right? Use a node selector. You can even add an additional taint if you wanted to further, keep other things from landing on there. So you would have 2 taints at that point. One for where's it at up here? One for this, infra equals reserved no execute, and then another one for, a taint called, application X, dot ingress dot, whatever slash, don't use. And then down here on your router, you would have both of those tolerations as well as a label or a node selector. And now I have a standard ingress node or a standard infra node. I have an ingress infra node, and my ingress infra node only has the routers, the ingress controllers hosted on it. You could do the same thing with logging, right? Create a second infra node type. Maybe it has different sizing, because logging can eat up a lot of CPU and memory. So different sizing, has both a taint for both infra as well as logging. My logging service, and we can see like down here, moving OpenShift logging resources. I add in, taints or tolerations. You can see this one has 2 tolerations. So I add in those tolerations as well as a node selector, which you can see here. We have a node selector here. And I've now pinned specific workloads on there. So you can have kind of this generic infra one, let all of my services that I don't care about or I don't want a specific or dedicated node type, they just generically select infra. And then for my specific ones that I want to have on, or my specific services that I want on specific nodes, I have both an additional node selector as well as additional tolerations to allow them to go into my special nodes, if you will. All right. I hope that wasn't confusing, because I feel like I stumbled over that explanation a little bit. Hopefully it makes sense to you, Johnny.
It made sense to me. I got it.
All right. So back to our cluster here. Hey, everybody's up and running. Let's see, where's my node? Extra large, double extra large. Here we go. YAML. Infra. So it's got our paint on here, just like we wanted it to. We can see it's a part of all the different things and all the different stuff that we need it to be. So just then as an example, let's go ahead and move our router. I'm just going to copy and paste these commands. I say that, but I don't have a CLI up, so I'll just use the custom resource definition thing here.
All right, so shameless plug. This is where web terminal would be really awesome. Like Andrew showed it, he's shown it before, but like I finally kicked the tires with it. Like it is awesome.
Yep, but you can do it all through the GUI if you're, a glutton for punishment, I guess. So all I've done here, just instead of doing OCGet ingress controller default, you can see all I did was go to the ingress controller custom resource definition and then select instances. And the only instance that was there is default. And now I'm looking at the YAML for it. So just like if I had done this command over here, I now have the YAML for my ingress controller. So we want to edit it and we want to change our node selector and add our tolerations. Get out of here. There is not an existing stanza with that name. Hit wrong. I've been switching back and forth between Linux and Mac, and this week, as I move between desks, and I'm back on a Mac at the moment, which means that I keep pressing Control C and Control V instead of Command C and Command V.
Yeah.
because, memory is real and painful. All right. Let's see. So one thing somebody asked about in an internal thread about, is there a best practice or a suggestion? Like you can see here, there's both a value of reserved. Actually, no schedule, no execute with a value of reserved. So in some part of the documentation, creating an infrastructure node. So here, label the node with infra equals, and then an empty space or in just a blank string. And then with the taint, there's a couple of different things that you can use as well, right? So pulling down here, look. So you can see this one doesn't have a value. It's just an empty string. OC Atom taint node name key equals value and effect. So infra equals reserved. So you can do the same thing of infra equals empty string here. It doesn't matter here. You can use infra, as I was saying before, with the if you have multiple infra node types, you could use this as a way of doing that. So infra equals logging, infra equals ingress, infra equals generic, whatever. And then you can use that in your toleration, or you can have multiple taints. What's the saying? 6 of one, half a dozen the other.
Yep.
Both of them work equally well. It's entirely based on how you want to manage your tags and everything. Let's see. So come back over here. Blah, blah, blah. Everything else is fine. So I'm going to go ahead and save that. I think that these are the taint. That's the taint that we put on there.
We put no schedule for sure. I'm looking at no execute. I'm curious if it's going to look for both of them, or if it's just going to be like
it won't require both of them, but it'll tolerate both of them.
Okay.
For anybody who's curious, so no schedule versus no execute. So Kubernetes taint. That big red banner throws me off every time. Kubernetes is blue. Why is it? So
danger.
Not schedule. No schedule. So no schedule means that exactly as the name implies, it won't schedule pods to that. I really thought that I'd find an easy definition of this somewhere in here, but that doesn't seem to be the case. So if a pod is already running on the node, when you apply the no schedule taint, it will leave that pod alone. But if that pod is terminated and then goes back through a scheduling process, it would not be reassigned to that node without having a taint for the no schedule, or a toleration for the no schedule. No execute, on the other hand, will evict pods from a node that don't have a toleration. And there's you can configure how long that takes based on a number of things, usually time-based. Yeah, see here, toleration seconds, 6,000. So if it hasn't, 6,000 is 600 minutes, right? 10 hours.
Yeah.
So yeah, basically after 10 hours, or no, that's seconds. So I can't math. I shouldn't math.
Yeah, I got you.
It's like an hour and a half.
Yeah.
2 hours, 2.5 hours. I'll get
Don't
there.
Public math.
Yeah.
Don't public math.
Don't. Yeah. Thank you. 3,600 seconds in an hour. So somewhere that puts us at like an hour and 3/4. Anyways, I'll stop embarrassing myself. So yeah, basically after 6,000 seconds, if the pod that doesn't have a toleration is still there, it will be forcefully removed from the node. So anyways, we'll save this. Our ingress controller, reload. Okay, we're good there. So let's come up here. So you can see the GUI has helpfully dropped us into the OpenShift ingress operator namespace. If I come up here to workloads, I don't remember if the ingress pods are also in this namespace. I think they are.
Gotta show the defaults. It's so stupid.
Thank you. So OpenShift ingress, you can see that we now have 2 that are pending. one that is terminating and one that is still running. Why are you pending? Let's look at our events. 0 of 8 nodes are available. Oh, so apparently we used the wrong toleration. This is what I get for assuming things. Controller instances. Here, go to the YAML. I'm guessing that the value is empty there, if I remember correctly. We can verify that by going back to our compute and looking at our machine set and our infra machine set.
Oh, it is empty. It is empty. Yeah.
Yep. So where are you? Taint definition. Yep. It just has a key with no value. So if you were quick-eyed there, all I did was for one of those, I removed the value. And this is a no schedule. The question is, did I remove it from the right one?
Yeah, I think no execute was on the bottom. I think you're okay. But double check, because
something Murphy's Law.
Yeah.
No schedule, no execute. Yeah, we'll take it off of both. All right. Now we can come back up here to our workloads, pods, ingress operator. Nope, I want ingress. So we got 2 that are pending. So let's see. Oops, not of terminal. 1242. So those are slightly old. I might need to kick those to let it.
Yep.
You're the new one. Now, why are you pending? Did not match affinity selector. I swear I know what I'm doing.
Oh, it's your node selector.
Yeah.
So if you look, like, I think it's looking for the node role on the actual, like when you do OC get nodes. That's it right there.
Oh, yeah.
So you'd have to go into your node or do like an OC label, the node name.
Yeah, but what did we put on there?
I think it's because it's doing it like through the machine config. So it's like instead of doing like the Kubernetes -role or whatever it is, node -role Kubernetes, whatever the hell it is.
Nodes. So here's one of them. YAML. Kubernetes, where are you? Instance type, nope. Arch. Why am I not seeing the label? I swear we added the label, didn't we? To the machine set?
Yeah, we updated it, but it doesn't actually like apply it for some reason.
That's so strange. Okay, well, let's brute force it then. Get this back just to move forward. But the real answer here is to make sure that the machine set is applying the right node label so that it can select it correctly.
Now you have infra worker, so you should be okay now.
4x extra large. Where's the other double X? There it is. YAML. Okay, thank you. So now here's our other infra/worker node. I must have worked something in our machine set.
Well, I went through this earlier and I saw it. That's why I was a little bit familiar with it, but I'm not sure. Maybe I did the same. Maybe it's because we copy and pasted from one instead of creating a new one.
Yeah, so they're both our router pods are now running, and they're running on the correct nodes here. I say that as though I can look at the name and tell exactly which one it is. Here, yeah, double extra large. So eventually we got there. I tested this yesterday and it was seamless, and apparently I just didn't change something or forgot to change something when I copy and pasted from a regular machine set. Anyways, I tested the the other thing as well. Control plane machine sets. But I did it on a standard IPI that deploys across the 3 AZs. And this time I pulled from a different thing, which should, didn't we just have this conversation about making sure that production and test match each other? And I just learned that lesson the hard way.
Hey, just goes to show, man. Anybody can do it.
Sifu mentioned VXLAN earlier. Is there a way to find out if a pod uses VXLAN with the gigabit limit? Talk with another pod. So the short version is if you're using OpenShift SDN, you're using VXLAN in between for pod-to-pod communication, assuming it traverses nodes. I think if both pods are on the same node, I don't think it uses the SDN. So yeah, OpenShift SDN is VXLAN based. So if it's pod-to-pod traffic between two separate nodes, then it will use VXLAN. Whether or not you're hitting that limit, I would say you'd have to test that yourself. Again, the documentation for that, in my opinion, for such a significant, I think, impact, 1 gigabit is a lot of throughput, but in the days of 100 plus gigabit interfaces on servers, that feels like a significant problem, right, or a significant restriction. So for such a significant thing, the documentation is very light on like conditions where it happens outside of VXLAN. And like anecdotally, I have seen where people are able to get more than that. So I feel like this is definitely something that you would want to test and verify for your application and your servers, your cluster deployment, as to whether or not that's being affected. It's also strange to me because doesn't NSXT use VXLAN, or maybe it used to? It might have switched to Geneve.
I think they moved to Geneve. Yeah, I think they were VXLAN initially. So
I'm curious as to whether or not, if this is true, were we seeing it before and didn't realize it? If I'm using, if I was using other VXLAN based technologies. I know there's multiple different hardware vendors that support VXLAN offload, stuff like that. Maybe it was being worked around that way. I don't know. So like I said, I just feel like there needs to be more details in the documentation other than, if you're using VXLAN, 1 gigabit limitation. Like I'm going to go with the trust but verify. Okay. So yeah, that's kind of all there is to it. As far as moving workloads, it's just like OpenShift Infra services are just like any other application workload. You affect scheduling via taints, tolerations, node selectors, the same affinity, anti-affinity, hence all of those other things. Just the way that you apply them is different because they're managed via the cluster operators. We can come down here to all our cluster operators, and ingress is going to be one of them down here somewhere. Ingress. This is how we control, how we manage all of these different things in OpenShift. But once you get down to it, once you get past how to actually apply those things to the pods in question, it's just like any other workload. All right. This is another long one, Johnny. This is 2 weeks in a row where we've gone almost 2 hours. So
this is good though. There's a lot of information, a lot of cool stuff.
Yeah, I don't know if anybody's noticed. I feel like I'm trying to do a little bit more of like the walking through the process and not the cooking show side of things. Because for a long time in the streams, it was here's this really cool thing, and I figured all this out and copy and paste everything in, and I'm trying to be a little more in depth with it. So I don't know if anybody has opinions, thoughts on it. Let us know. Again, you can reach out, chat for the next few minutes while we're still here, but you can also ping us on email, various social medias. Let me find the right button here to press. Andrew.Sullivan at redhat.com or Johnny, Jonny at redhat.com. But yeah, with all of that being said, I don't have anything else. What we got coming up in the next few weeks, Johnny? We've been talking with a number of people about a number of different things happening on the show. So
yeah, I mean, so we've got a few weeks from now, we've got for sure. Oh my God. Oh, HashiCorp Vault. we have Rosemary from HashiCorp Vault. She's going to come on and she's going to talk to us about, essentially give us a run through of like what HashiCorp Vault is in Kubernetes and OpenShift, and then how we can use it in OpenShift and some of the benefits. So I think that's going to be a really cool demo. She's really excited.
You mean to tell me that base 64 coding in its secrets isn't secure? What?
No, it is. It totally is. It totally is. But
until they figure out base 64 space dash D, and then
then you're in trouble. But yeah, she's we've talked to her. Like, we've had some great back and forth so far. So she's looking forward to coming on the show. Like, I'm excited that she's coming on the show. I didn't want to speak for you and say that we are, but
I am. I'm always excited.
I think it's going to be good.
I get to see your smiling face, Johnny. That's
right. That's all I can ask for. But then what's the other one? We have a couple of partners that we've been talking to that we're trying to like confirm some stuff. But that's the big things. We've got a few partners and a bunch of good stuff coming. It's just a matter of getting schedules locked down.
Yep. And before you know it, 413 will be here, and we'll be talking about 413.
My God. So, yeah, I know.
This year, the whole thing about like as you get older, time seems to go more quickly. Like that's this year.
Yes.
Like January was like it's just accelerating as we go on.
So. Yeah, it has just flown by. I mean, like just this week alone, right? I feel like I woke up and it was Monday, and I went to bed and I woke up and it was Wednesday. It just seems so far.
Yeah. Well, all right, y'all. So thank you, everyone who has tuned in, who's listened to us live here. Dwayne, I see you have a question here. Is there an operator's cheat sheet? Yes-ish. Let me reshare my screen here. So let's go back to the documentation. And I think it's under here. There is... No, that's all for creating. There is a cheat sheet somewhere that talks about cluster operators. Operators reference. Oh, that was easy. So I'll paste this into the chat here, using the search for what it's meant for. But you can see here in the table of contents, it goes through for all of those cluster operators. So from the CLI, if you do an OC get CO, or as you saw from my console here, if I come here to cluster settings, cluster operators. So for all of these guys, there is an entry in here that tells you what it does and kind of how to poke around at it. I'll also point out, I need to, now I wish I had a cluster running. Do I have a cluster running somewhere that I can use to show something real quick?
And I'm going to share a link also, just in case you're talking about building operators, because I'm not 100% sure. But if you're talking about building them, here's the operator SDK, which has the different varieties. So you can either do it through Helm or Ansible or Go. This is the Go edition, but if you just dig through the documentation, they walk through actually building an operator and all the resources. So it just depending on which way you're asking that question.
All right. Let me share my.
And Andrew, just real quick, we had a question from Mira, and I'm sorry if I butchered your name. A training certification question from 4.6 exam to, is the 4.6 exam too different from 4.10? Were there many features added to 4.10? I would say, personally, and Andrew stomp on this, right? Like if you can take the exam on 4.10, I would take that because there's some API changes that happened in 4.9 that won't be accounted for. You might be studying for them in the training that are in 4.10 and take a 4.6 exam that might not have those changes implemented. So it could cause some confusion.
Yeah. I would also say, 4.6 is no longer supported. So
yeah.
So the command I wanted to show, Dwayne, is this OCADM release info -- commits. So what this shows us, hopefully it stays readable as I expand this to make it readable. So what this shows us is for each of the cluster operators here, and you can see this big old list that goes down through here, or for each of the images, I have a GitHub repo that's associated with it. So let's pick on, let's click on or pick on the cluster ingress operator. So I can go to this particular GitHub repo. So let me share my other window here. This is why I try to use the browser-based thing and just forgot to set it up. So if I go here and see the exact code that is behind all of this. So one thing to note, so that -- commits, there is a commit ID out to the side. So you can see like the precise commit where it was up to when it was included in this particular release. But these are interesting. These GitHub repos are interesting because a lot of times the engineering folks who work on these will include a lot of different information inside of here. So I would say sometimes be careful because there might be unsupported things that are in here as they go through and document like how to do development on it and all this other stuff. But you can learn just a huge amount of information about each one of these operators by looking in the GitHub repo, as well as if you're ever curious about like the literal implementation, like how to, what does the code look like? You can look at it. One thing to check for, all of these that I've looked at all have branches for each release. So we're on 4.12 right now. So you would go to the 4.12 release, and this would be, the branch that it uses for ours, because it does change, especially MCO. The different files that they manage automatically through MCO changes over time, and so pay attention to which release you're actually looking at there. But yeah, I found this to be hugely, hugely helpful over time. So yeah, great. Thank you, Dwayne, for the question. Yeah, so OCP 4.10 exam, there was a bunch of features added between 4.6 and 4.10. So features wise, yes, there will be some things, but I think to Johnny's point, a lot of it is just the core APIs and stuff like that. Yep. Okay. So I think we got to all the questions. Yeah. What's new in 4.10? Thank you for the link to that, our Hope 9. You would also want to look at the what's news for all of the versions in between there as well. So 4.7, 8, and 9, because we don't have cumulative versions of those. I think that's the right word. There'd be an episode on how to add custom catalog operators to a cluster, add them in disconnected clusters. We touched on that during the disconnected deep dive, which is way back in the 40s, I think. I think we ran out of time when we did that, though, so I don't think we got in depth with it. It's also changed quite a bit now that we have the OC mirror command and stuff like that. So it's a good call out. Let's add that to our list of things that we can talk about, because disconnected has been changing for the better over the last few releases.
Yeah, we could probably do like another long episode where we do like a disconnected install and then do an updated catalog where, just like she's asking, right, where we bring in maybe cluster logging or something like that, and then create the catalog source, ICSP, push it out, and then deploy it.
Yep,
that's a good one.
All right. So I got nothing. Again, if anybody is, whoever's watching us live, if you're not watching us live, anything comes to mind, so feel free to reach out to us. Johnny and I love to hear from y'all. And also I'll add in the Kubernetes Slack is a great way to reach out to us. We're both on there, and I try to keep up with what's going there. Yeah, I know it's the community side, so there's a lot of OKD questions that OKD is just different enough for me that I feel unconfident, or not. I don't feel confident answering questions all the time. But yeah, other than that, we will be back next week. Yeah, there's nothing that we'll be here next week.
Yeah.
I got to think about it because I feel like between one or both of us, there's been so much going on that we've missed here and there.
It's only March.
Yeah, don't know what the topic will be next week yet, but we'll definitely be back. So thank you, everyone. Love seeing you here. Love all the chat. Johnny, I will throw it over to you for any last words.
No, I got nothing else to say. Thank you. Great seeing everybody.
Bye now.